Hello everyone, welcome to this video and my channel. If you are visiting first time to this channel, please subscribe my channel. Thank you. Let's start today's topic. So in this video, we are going to talk about regression. See what is regression. Actually, if you see this data, so whenever you have data and you have a problem, like suppose in this data, I have a problem to, I want to build a model. That model will predict the target. Suppose someone will provide me new feature. Maybe here you can see someone will provide me 22, and I want to know what will be the target here. So basically, I want to predict something. It means I want to make a relation between feature and target. See, whenever you know your target, whenever you know exact what you're trying to do, it means it's a supervised problem. Because here we have the feature and the target. It means each data is labeled with the target. So it's a supervised data. In supervised, maybe your problem will be regression or maybe it will be classification. If your target is a continuous data, see this, my target is just continuously changing. It's a continuous data. So it's a regression problem. Suppose it's a categorical data, maybe like either 0 or 1, maybe binary classification, maybe 0, 1, 2 only. So multiple classification. So that's a classification problem if target is a categorical variable, but it's just a continuous right now. So it's a regression problem. So this is the problem like data, supervised and regression. Now let's talk about how we build a regression model. See, regression, there is some assumption about regression. Okay. Right now, I'm taking one assumption, and in coming videos, I will talk more about that. So let's talk regression through scratch, and we'll discuss everything in detail. See, so we have this data, and if I plot this data, and suppose it's a linear relation, and suppose I am plotting this, maybe this is my feature, and this is my target, and suppose this data, I'm plotting this data, and suppose this data looks like this. Okay, maybe. So there are some outlier as well in this data. So I want to I plotted this data. Okay. And I want to make a regression. See, regression means a simple line equation. Basically, we have this, target is an independent variable. This target depends on features. So whenever you are doing a regression, we have a target and rest of all these features. So basically target depends on feature. Right now we have one feature and one target. It means it's a single linear regression. So we'll talk right now about simple linear regression. Okay. See, so we have this target and this is the feature. So basically my target depends on the feature, right? And I believe you know the line equation from our 10th mathematics. So line equation generally looks like mx plus c. Okay. C just your intersection and M is the slope. So right now I'm trying to write like this: y is equal to omega naught plus omega 1 into x, not M and C, because most of the book you will find they wrote like this. That's why I wrote this. Okay, let me remove this part. Anyway, now see, we have this y is equal to w naught plus w1x. Suppose this is my assumption that this line is perfect for this data. And if I draw the line, suppose it looks like this. So basically, this is my equation, that is w naught plus w1 into x, right? So just see this. This is by basically the interception, that is w naught, and there is a slope here. Okay, if you check the slope, so if you just make a line here, and if you see, this is the, suppose this angle, and maybe this angle is theta. So this slope w1 become tan theta, right? So this is w1, w1 is tan theta, and this is w naught. Okay, so if I able to draw this line, I will get this angle. So from there I can get this W1 is equal to tan theta, and this is my intersection. So I will have this equation. Suppose maybe doing all this calculation, maybe we know the theta, we know this value. Maybe our equation become like 2 plus 3 into x. So now someone will give the feature, this data, like someone giving maybe 10 here. So I will put this 10 into this equation. So now this become, I think, 32. So my target will be 32 for this data. Okay. But now there is a problem here. How can we know this theta? How can we know this W naught? So basically the problem is, how do we know this W naught and W1? We have to calculate this. Okay. So till now, I just try to explain you whenever you have a data problem, if there is a defined target, it means a supervised problem. If your target is continuous data, it means it's a regression problem. Now, if a regression problem, I want to build a relation between dependent and independent variable, so I can predict something. Okay. So if you want to make a relation, definitely regression is a line equation. So I generally took any assumption that I'm just taking any simple line and try to find out what will be this W naught and W1. So this will be the exact line, right? I just make this assumption that my equation is this. So I have to find this W naught and W1 to, maybe we have to do something I will do right now. So do some mathematical process and anything and try to find this W naught W1. This is now our aim. If you are able to find this value W naught W1, then after you are able to predict, right? So is it easy to find this? No, it's not easy. Yeah, nowadays we already package available in Python. We can call those package and it will return W naught W1. I will explain those packages as well, but right now my assumption, right now I'm trying to do. I'll first explain you through Scratch. We will write a code also through Scratch. After that, we will do everything with package also. So you will have a better understanding how regression actually works, and then we will do through package. Okay. So let me clean this pen, and then I'm going to explain you how can we find this W naught and W1. Okay, so I draw this line. Okay, this is our assumption line, and this is the data. Now see, let's try to find this W dot W1. So I'm going to, explain you the maths behind this and how can we find the W dot and W1 with this scratch. See this? Suppose I'm talking about this point, and maybe this point is, maybe let's talk, this is X1 point. This is X1 point here. And if you see, the real value for X1 is, maybe Y1 is here. This is my Y1. Okay. So this is my Y1. This is the real data available with us. So this is X1, and so this is basically the feature one, and this is the target one. Just told right here, X1 and Y1. If you see for this X1 data in our prediction line, for this X1, we are predicting this YP1, right? So basically, there is a gap here. Let me write loss. So this is gap like YP1 minus Y1. Similarly, on each point, we have some gap. So let me write like this: YP1, YP2 minus Y2, then YP3, YP3 minus Y3, and for each the data. Right? See, there is a problem here. What is the problem? If you want to add all the gap, there is a problem here. What is the problem? See, sometimes your gap is negative, sometimes your gap is positive. So if you try to find overall gap, some gap may be cancel out. Avoid this problem, avoid the cancel, let me square each the point. Okay. This is a good way to do this. Just square everything. Now it will not the cancel out, because if you square the negative, it will become positive. Okay. See, there is a advantage also, because see, there is a more high loss will penalize even more, because we are doing a square. But anyway, don't go into that. Let's try to explain a thing like this. Because you have a negative and positive, if you add everything, it will cancel out. That's why I square it. Now see, what is YP1? YP1 is nothing but W naught plus W1 X1, this value. So this is the YP1, real is Y1. Same if you go for YP2, what will be this? W naught W1 X2, YP3 W naught W1 X3. See, this W naught W1 is constant, right? For this line, we're only changing the this values, and due to this, prediction is changing. But good news is that we already know what is the real value for x1. We know y1. For x2, this is y2. For x3, this is y3. Because right now we're trying to see whether this assumption line is correct for given data or not. If this is okay for sample data, then we may predict for future also. Maybe we can think for population. But right now, we are talking for sample data. So, we just saw there is a gap here, yp minus y1, yp minus y2, yp minus y3, and maybe sometime this gap will be negative and positive, so it will cancel out. That's why we did square here. Now, if you put all the value in the loss, like yp1 value, yp2, so let me put this. Let's try to think what will happen. So let me delete this first. Let me delete this also. Okay. Now, just give me a minute. Okay. Now, if I wrote this equation, this loss equation, okay, let me delete this as well. Let me delete this as well. Now see what will happen here. Okay. So now if I writing loss here, so my loss will looks like this. W naught plus W1 X1 minus Y1 whole square. W naught plus W2 X1 minus Y2 whole square, like this, right? See, actually, we are looking for this W naught and W1 value. But now let me reframe my sentence. We are not only looking for W naught W1 value, we are looking for this optimized W naught W1 value. So this loss will become as much as possible, become minimum as much as possible. See, this is loss, right? Maybe it looks like this. I want this minimum loss, right? So I know I want looking for this W naught W1 possible, so I got this minimum loss. If this is my loss function, this is my loss function. If it looks like this, I want this point. I need this W naught W1, so I got this minimum loss. But right now I don't know where it is exists. Okay, no worry. I don't know you guys are able to recall this or not, but let me try to make you understand. Just give me a minute. See, in our 10th or maybe 12th level math, we know one concept that is called minima and maximum. So if there is any function, and if you're looking for minima and maxima, what we do? First we differentiate this function, then put it zero, then do double differentiation, get the value from here, put it here. If it's negative maxima, positive minima. So in the similar way, we'll do here. Actually, we want to calculate minima. So what we can do here, let me explain you. And that is simple actually. See, we can do one thing. We can just differentiate this loss function with respect to omega naught, put it 0, then again differentiate with omega 1, put it 0. And if we do like this, do the all calculation. I'm not doing this, but yeah, if someone is looking for that calculation, just write in the comment. I will make a video on that. I already created one video, but that is not there. So if you looking for this, just let me know. I will make video one video for that. So if you do like this, d loss tw naught is equal to 0, d loss tw1 is equal to 0, your w1 value will become covariance. This will, you'll get the result covariance x comma y divided by variance of x. In our data case, it looks like this: covariance feature comma target divided by variance of feature. It looks like this. Okay. And W naught, we already know this, very easy. If you know this equation WP, suppose I'm writing W naught plus W1x. Actually, this is the expected value, so meaning actually the average one. So the W naught will become actually Y average minus W1x average. And you already had this targets, you get the average. We already had the feature, we got the average. And we already calculated W1 from this equation, put it here, we'll get W naught. So we now we have this W1 and W naught. Now let's implement this regression through this in Python, and then again I will come to this equation. Don't worry. Let me first do this. Okay. So I don't know you guys are aware of this covariance equation or not. Let me explain that also. So basically W1, here we got W1. W1 is equal to covariance of x comma y divided by variance of x, right? What is covariance of x? This is basically summation x minus x bar into y minus y bar divided by summation x minus x bar whole square. This is called variance, so just cancel out. So this is basically the W1. Let me do this through Python, and we will also do through the package. Okay, no worry. So I still is not completed. Okay, the lots things we have to do in the regression. So let me go here. See this. Okay, so let me load the data using Panda. This is the regression data.csv. So this is the data we already know. In this data, we have feature and target. So what I did here, I take, I plotted here also. Let me go here. Yeah. So see, I just take this data feature and target, convert it in NumPy here. So my equation will become very easy. So just make it here. Then I calculated the average point, minimum for feature and mean for feature and mean for target. Then I calculated this W1. I already wrote the equation x minus x bar y minus y bar divide x minus x bar whole square. This is W1, and then W naught. Let me run this. See, we got this W naught and W1. If you want to verify this through the package, let me go for the package as well. See, this is the data. So I take X feature and Y is target. I'm importing this Python package linear regression. So from sklearn.linear model import linear regression. I make the model, fit this. Let's see the intercept. First, let's see the coefficient as well. So if I see the coefficient, what will be the value? 3.9 something, and we got this also 3.9. Let me show here where we calculated. Yeah. See this W1 is 3.9. And intercept, if you want to looking for intercept, let's check that as well. See, you got minus 6.35 something, 6.35. So similar we are getting from the package. See, now we have to check two, three things more. That's very, very important. Like we have to check the T test and F test. I will explain that also. Because see, we have to see whether this feature uh, really depend on target or not. So definitely we have to do check the coefficient, and we have to check the T test and F test. So I will explain that also. But right now, I want to explain one very, very important concept here. Let me explain you. See, our W1, we got this covariance of x comma y divided by variance of x. My YP equation is equal to W naught plus W1 into feature, right? If my W1 0, YP becomes just W naught, only a constant value. Now my YP looks like this. It's not changing with feature. It means my target is independent. It's not depending right now on feature. Okay. Even if you are able to recall the correlation coefficient formula, that is basically covariance of x comma y divided by standard deviation x and standard deviation y. And if we know this correlation coefficient, it actually tells us what is the relation, how much the relation. If it's one, highly related, if it's zero, no related. So W1 zero, it means this is zero. So here also it will be zero. That means correlation coefficient will be zero. It means there is no relation. So even this W1, what is suggesting here, same things we will get from the correlation coefficient as well. That's why all these things are correlated, right? If you know, that's why if you want to regression, you have to know what is covariant, what is correlation coefficient. If anyone have issue into this, please write in the comment. I will try to make a video on that also. Okay, so that's way. Now in the next video, we'll try to understand what is, RMSC root mean square error, what is MSC mean square error, what is, R square, how it will depends on all these things, right? So we'll discuss everything, in the next video. Thank you so much for watching this.